This is video 3 in the naming compounds section. This is all about naming with polyatomic ions. They actually follow all of the same rules that we used with ionic equations, except for the fact that we have to recognize when we are using a polyatomic ion. These are the 6 polyatomic ions that we're going to have you work with. First one is nitrate, sulfate, hydroxide, ammonium, phosphate, and carbonate. The biggest thing is that you need to be able to recognize these when they're being written in compounds, because it's going to be very difficult to try and individually name these, because really you can't. So let's look at a couple of examples. So the first thing we're going to do is we're going to write formulas from names. So you have to keep in mind that there are a couple of things going on now. So in video 1, we talked about how there are elements, or metal elements, with a constant charge. Those are in group 1, group 2, aluminum, zinc, or silver. So the first thing we need to do is realize whether we're working with transition metals or if we're working with metals with a constant charge. What's nice about writing formulas from names is that you really don't have to worry so much about what type of metal it is, because they're kind of giving you the hint. The hint in this example is that there is a Roman numeral. The Roman numeral here tells you that you have a variable charge metal. In this case, it's iron. So Fe, and the Roman numeral tells you that it's +3. Here's the part that you have to memorize. This is hydroxide. We need to know that hydroxide is OH with a -1. Together, you're going to end up with Fe, OH, and there's 3 of these OH units. So if you have more than one polyatomic ion, you need to use parentheses. So you might want to make a note to yourself here. More than one, we're going to call it polyatomic ion equals parentheses. So we just have to be careful on that, because unfortunately this is not the same thing. The reason it's not the same thing is when I have parentheses, the 3 applies to the H, and it also applies to the O. In the case up here, the 3 would actually only apply to the H, so we have to be pretty careful on that. Let's look at examples. So the first one is silver nitrate. Okay, notice there's no Roman numeral there, so I'm expecting you to know what the charge of silver is, and this charge on silver is Ag +1. And nitrate you need to know as NO3-. So if you're not quite up to speed on memorizing your polyatomic ions, definitely something that you want to catch up on. So together this would be AgNO3. Note that I'm not using parentheses here because I don't have more than one NO3. So here I have copper 1 sulfate. I do have a Roman numeral. Roman numeral means I am working with a transition metal. So copper is Cu, it has a charge of +1. Sulfate is SO4 2-. Again, the sulfate, ATE ending is a good symbol that we're not dealing with sulfur. If it were sulfide here, we would be dealing with S2-, but we're dealing with sulfate. So we're dealing with SO4 2-. Together, this is going to end up being Cu2 SO4. So the next one is a little bit more challenging because you really do have to identify whether you have a trait or not. So this is writing names from formulas. So the first one I'm giving you here is sodium, and sodium is in group 1, so that doesn't actually have to have a Roman numeral. So we're going to go ahead and write sodium, no Roman numeral, and NO3, you should know at this point, as nitrate. Be careful with the ending. If you add IDE, then we're just talking about nitrogen. In this case, we're talking about NO3, which is different. So this example is Fe3PO4. Fe is a transition metal, and it is iron. So I'm going to go ahead and write iron with my parentheses and leaving space for what the charge is. PO4 is phosphate. So now I have to figure out what that Roman numeral is. So let's go back to our old tried and true method of trying to figure out what that is by using our dotted line in the middle. You have to remember PO4 as a unit is -3, Okay, and there's one of them, so this is a charge of -3. And on this side, it would have to be +3, so it would be iron 1 phosphate. Probably doesn't exist, but it worked pretty well for my example here. All right, so let's look more. I put 3 here. One of them is kind of an exception with one of the weirder polyatomic ions, which is the bottom one, but we will get to that point. So here's Ni. Ni is nickel, which is a transition metal, so this is going to be nickel with something in parentheses, and CO3 is carbonate. So we can come over here and kind of take a look at what we have. So CO3 is 2-, so the overall charge here is 2-, making nickel +2. There's only one, so it's going to end up being nickel 2 carbonate. Okay, so if I look at the next one, Mg, magnesium, is actually in group 2. So it's in group 1, group 2, aluminum, zinc, or silver, which means it doesn't need a Roman numeral. So this is magnesium, and NO3 we know as nitrate. So this is the weird one I was talking about. This is NH4Br. NH4 is the only positively charged polyatomic ion that we gave you to memorize. So this is ammonium. And because ammonium always has a charge of +1, there's absolutely no need for any kind of Roman numeral. And this is going to end up being bromide. I threw the bromide back in again just to remind you that if I have a single element, the ending's going to end up being IDE. All right, that's the end for this one. We're going to move on to molecular compounds, which are made up of 2 nonmetals in video number 4.